Every robust data architecture begins with a clear blue. We look at data modeling through three distinct lenses of abstraction. First, the conceptual model. This is our big picture view where we identify high level business entities and their relationship without worrying about technical constraints. Next, we move on to the logical model. Here, the structure becomes rigid. We define attributes, primary keys, and relationship in detail, but remain technology agnostic. Finally, we reach the physical model. This is the actual implementation, the DDLs, data definition languages. It's where we account for the specific database storage formats and indexing strategies that will turn a living system. And when it comes to the organizing analytical data, the shape of your schema dictates your performance. On one hand, we have star schema, the gold standard for simplicity. With the central fact table surrounded by denormalized dimension tables, it's built for lightning fast joins. But the system's scale, we might look forward towards the Snowflake schema. By normalizing dimensions, we reduce data redundancy and save on storage. Though at the cost more complex query joins, in modern complex designs, the key is balance. Notice the use of surrogate key. These are essential for decoupling your warehouse from source systems changes, ensuring your relationship remains intact when the business logic shifts. And in most of the cases, data isn't static, it evolves. Handling those changes is where slowly changing dimensions or SCDs come into the picture. Type 1 is the simplest. We simply overwrite the old data. It's clean, but we lose all the history for it. And there's a type 2. In this, the workhorse of data engineering, we add a new row with version or a date range, allowing us to track exactly how an attribute looked at any point. And there is a type 3, which offers a middle ground using new columns to store the current and the previous values. Choosing the right SCD type is a trade-off between the depth of historical insights you need and the storage complexity you're willing to manage. And the final step is the modern data engineering is matching your design to. If you are building an OLTP system, normalization is it ensures data integrity and fast writes by minimizing redundancy. However, for OLAP and analytics, we shift towards denormalizing to prioritize read speed. Think of your indexing and partitioning as the speedometer of your cluster. A well-indexed table can mean the difference between a query that takes seconds and the one that takes hours. By strategically applying surrogate keys and performance tuning, we ensure that the architectural blueprint we started with actually delivers at scale.